Welcome to Mathematics Olympiad. Today I will talk about the inverse trigonometric function and also a trigonometric equation. All right, trigonometric equation. So to explain this class, I need to show you what is the trigonometric the properties of inverse or inverse trigonometric function. Okay, let me write what is the trigonometric properties of inverse. It's very important. You remember this trigonometric function. All right. I will write one by one. Okay. Let's write here the function, and then domain. We have domain. We have a domain, and also we have range. That's very important. And then monotonicity. This is four different things that I will talk about. So, and the first one we have here, for instance, y equals arc sine x. So the domain is about -1, 1. The range we have in this property, we have a negative pi divided by 2, and then positive pi divided by 2. Here, the modesty is increasing. So the number 2, we have y equals r cosine x. Then the domain is we have -1 and 1 here, and then we have this one here as 0, pi, like this. All right, this is decreasing. This is decreasing. All right, we have another one, y equals r tangent, right? And then we have here negative infinity to positive infinity, right? Then here the range is it is a different meaning. Okay, negative pi divided by 2, and then positive pi divided by 2. Okay, this is increasing. All right, the next one we have y arc cotangent x. Here we will have a negative infinity to positive infinity. Here we will have 0, pi. Here is a decreasing. The modesty. Okay, so this is a properties or inverse of inverse trigonometric function. All right, keeping in your mind this clue. Okay. I will solve a couple of problems. All right, but before I need to give it this kind of properties. So the next step is identity. So identity among among trigonometric function. There's another thing that we have to know before to work in mathematics in this kind of the problem, okay? So number one, so we have four. Number one, we have like this r sine x plus r cosine x. Cosine x is equals, this is kind of identities. Is equals pi to 4 x belong to -1 and 1. Okay, this is our first property. We have identity. The second one, the number two, property number two, we have r tan x plus r cotangent x is equals pi divided by 2 for x belong to r. I mean the real numbers. R mean real numbers. Number three, we have r sine x. Sine x here times equals x. For x belong to negative pi divided by 2 and positive pi divided by 2. Okay, we have this another identity. The number four, identity number four, we have a sine is like this times arc sine x equals x. For x belong to -1 and comma 1. Okay, four identities. So very important, remember this kind of the rules before to solve Mathematics Olympiad problems. Belong to these big issues, big tests, big challenge. Okay, but I like to give it to you some clues before to work in my mathematics problem. So the first problem, let me solve this problem. Find all real solutions to the equation. Let's write my equation. The equation is about sine. This is our equation to the third power plus cosine to the fifth power x equals 1. So this is number one, right? All right, this is our problem. Look at this. So therefore, to solve the problem, we have to give it some clue to our problem. If we write it, for instance, our problem in this way, sine to the third power of x is this of x the sine we are talking about the sine to the third power x plus cosine 5 power of x cosine to x, right? So you will write it this less than write absolutely value sine x here to the third power, all this to the third power, less or equals again sine x to the second power equals sine to the second power x, right? The other thing is if we have a cos to the fifth power x less than remember the properties and the qualities I give it to you before. This is this for this reason, okay? So cosine x to the fifth power less or equals than cosine x to the second power. So equals cosine to the second power x, right? Okay, so I will write my problem and I keep find the solution and I erase it because I don't have enough space. So we have then a sine to the third power x right there plus cosine to the fifth power x less than sine to the second power x plus cosine to the second power x equals 1. It's for those two reasons. All right. So now combining, let's we have to combine this. Combining here, combining it with 1. So we have 1 there. So we have. So I write it. So that's why we combine. We combine it there. We will have here then sine to the third power x equals sine to the second power x and right and cosine to the fifth power right x equals cosine to the second power x, right? The first equality here, the first equality requires that let me write it maybe. I mean, the first equality, this one, requires that that is another step. I write it because later we don't know why. So sine x belong to 0, 1 right there. See, and the second equality requires that a cosine x belong to also 0, 1. All right. Since here, since sine to the second power x plus cosine to the fifth power x equals 1. So I mean this equation, we get it here we get it parenthesis here, sine x cosine x equals 1, 0 or 0, 1. All right. It's like this. So therefore here, let's write it. Therefore x is equals to k times pi, or look at this, very important, 2k pi plus pi divided by 2 with k belong to 0. I mean the whole numbers. Okay. I will erase it to this point here to give you the information to the conclusion. All right. Almost done. Almost done. So I will erase it at the top right here. Not everything. Just next to here. So then we have, in fact, for all, I mean, M and N, greater or equals than 2 with 2, comma, N belong to N. I mean, in the natural numbers, this is the natural numbers. The equation, I'm trying to find the solution to this Mathematics Olympiad equation. So the equation, we have is sin, or mean sine M x plus cosine n x equals 1, right? So find all real solution for the equation. So in this way, this is the equation right here. You have it with can be solved for the same methods, okay? So, but this is the solution right here. Is our conclusion is the solution for this mathematics problem. All right. So let me show you another Mathematics Olympiad in this topic. Let's see another problem. Next problem is find the value. Find the value of the following the following sum. It is a sum in this problem. It's very complex problem, okay? So we have arc sine of square of 3 divided by 2 plus arc sine of square root 8 minus square root 3 divided by 6 plus, this is our problem, arc sine. That's why I give it to you before the properties. If you don't know the properties, it's very hard to solve this kind of problem. So square root 15 minus square root 8 divided by 12. Okay, that's our problem. Plus going on some plus arc sine of this is going to be big, all right? Right here we have m plus 1 squared 2 minus 1 right here minus square root n to the second power minus 1 divided by n times n plus 1. All right, it's right there where here what I mean n, so where n is giving positive integer. All right, so this is okay, the solution. Let me write some question about the solution. So we have here, let's So let's end the note as sum above. All right. So where calculation, the sum or the sum by cancellation. In fact, let's write here. In fact, for 1 less or equals than k less or equals than n with k being positive integer we are able to prove this one r sine long process here, square root we have m plus 1 to the second power minus 1 is right here, minus a square root k to the second power minus 1 divided by k times k minus 1, right? Equals, this is equals, we are able to prove this one r sine 1 divided by k minus r sine of 1 divided by k plus 1. This is number 1, right? The number 1 right there. So both sides, one side of 1 are acute angles. So let me write it for you. So one thing here, both sides are acute angles. All right. Angles of 1. All right, let's write of 1, right? So the second thing, we have to take the sine. So take the sine, taking sine on both sides. Both sides of 1, right? So this is our next step, right? So I will erase everything to solve my problem, okay? So now let's erase it here. I want to keep the problem there. So let's write it here. I use this color. Sine of this big equation right here, arc sine of what we will have here, the square root of k plus 1 to the second power minus 1, right? Minus square root k to the second power minus 1 divided by k plus 1 here, k times k equals is a very large problem here. Again, is equals, we write here x plus 1 to the second power minus 1 minus the square root right there, x to the second power minus 1 and divided by k times k minus 1, right? That should be the right. So here we will have sine here, sine, we simplify here, r sine 1k here, 1 divided by k minus r sine of 1 divided by k plus 1, right? So now this is will be equals. This is right here is equals. Right here, let me write equals right here. So we will have sine here arc sine k divided by k 1 divided by k cosine of arc sine 1 divided by k plus 1 plus 1, right? Here, oh, and this problem is plus, not minus, it's plus. Okay. And everything is plus right there, see, plus. So now minus, we have to write here minus cosine of arc sine of 1k sine of arc sine of 1 divided by k plus 1, right? K plus 1. Okay, that everything is going to be equals here, almost done, all right? Equals, we'll have 1k or 1 divided by k times, going to be times right here, times the square root, everything here is square root, 1 minus 1 divided by k plus 1. Remember, in the bottom, the denominator, to the second power. To the second power minus 1 divided by k plus 1 times here, times square root, again, square root 1 minus 1 divided by 2k, 1 divided by k, 1 divided by k to the second power. All right, this is will be equals, we'll have here a square root x plus 1 to the second power minus 1. Minus 1 divided by k times k plus 1. Here minus, we will have here k to the second power minus 1 divided by k plus 1 times k. All right, we're there. So from this point we are able to get the conclusion. This is minus, right? Okay, minus sign minus. This is times. All right, got it to this point. I'm gonna give it to you the conclusion, because find the value of the following sum. We have to find the value of this sum. This is our problem through here. Remember, this is Mathematics Olympiad, very complex problem. All right, I will erase it all this process and I give it to you our conclusion from this point, right? From that point. So from the last point, so we have let me write hints. So number one, we did before holds by number one, right? We have to write is n equals arc sin. I mean not sin, sine of 1 divided by 1 minus arc sine 1 divided by 2 plus we will have arc sine of 1/2 minus arc sine of 1/3. So we have those plus here plus. This is our conclusion, right? Arc sine of 1/3 minus arc sine of 1/4 plus, remember these points, plus we will have here arc sine of 1n minus n, not 2, n arc sine, I mean here minus arc sine of 1 divided by n plus 1 here, right? Equals, this is plus now, equals arc sine 1 minus arc sine of 1 divided by n plus 1 equals pi divided by 2 minus arc sine of 1 divided by n plus 1. All right, equals arc cosine 1 divided by n plus 1. Right? So therefore here, therefore the decided sum equals arc cosine is 1 n plus 1. That's it. That's our conclusion. All right. So Mathematics Olympiad. This is these kind of problems are very complex. We need to be very smart, and then we have to know a lot of properties. In this case, I give it to you before the properties. That's why you see some weird number right here. It's coming from the properties. I give it to you to the beginning. So thank you so much. I'm waiting for you next Monday. Remember Mondays and Thursdays mathematics with